Good afternoon, everyone. Thank you so much. You are waiting until now for the last presentation in this afternoon. My name is Huang Ling. Come from Chihu 360. Our team is focusing on the radio and hardware security. Okay. My presentation today is about the LTE security, about a kind of attack to redirect the cell phone into, downgrade into the weak secure network. Okay. We know that 4G network, i.e. the LTE network, is more advanced, secured, but it doesn't mean it's absolutely safe. So in last year, in the Black Hat Europe, there are presentations introduced the LTE IMSI catcher and DOS attack over LTE network. This picture shows the tool they use, laptop plus USRP. We will also use such tools to do further attack, to do redirection. Okay, let's first see the two known attack types. The first one is about IMSI catcher. You can see the left part is the real LTE network controlled by operator. And the attacker can build a fake LTE network, the smaller one, which covers a narrow coverage area, okay? Once the cell phone enters into this area, it will try to attach on this fake network, and the network will ask the cell phone to send its IMSI number. This number will be reported to the fake network. Then we can get the unit, the identification about the cell phone. As I know, there are some national security departments are using such device to track some criminal suspect. And I also heard some rumor that there are some under casinos that use such device, porting nearby their casino to know if there are strangers come nearby, and they will get alert. So anyway, from the network side, we don't wish such active equipment to influence the existing network, right? No matter it's by government or by some illegal entities. The second attack example is about the DOS attack. In this case, yes, we also use the fake LTE network, and after the cell phone sends its IMSI number to the network will send back to a attach reject message. This message will carry some special courses. These courses will make the cell phone shut down its modem and did not connect to the network for a very, very long time. So it is called a DOS attack. For me, I did a further step. After we send the attach reject message, I added some further information that calls redirection message. This message will tell the cell phone, okay, you come into my GSM network. What is this GSM network? It is also built by the attacker. It can be a fake network. I mean, it may be built by OpenBTS software, but also can be other malicious 2G or 3G network. So in this case, as long as the cell phone enter into this weak network, 2G or 3G, the voice or data traffic can be eavesdropped by the attacker. This is the risk of this attack. Usually people will argue that we could use some other simple way, like jamming signal, right? You can jam in the existing 4G network, and then the cell phone will automatically downgrade it to 2G or 3G, right? But the advantage of this attack is you can choose the target. You can choose to tell this cell phone go to that network and tell other cell phones go to operator's 4G network. So the other people will be not influenced by your attack, right? I will show a demo to you, but firstly, I want to introduce the system, the platform we use. The left part is a fake GSM network. We use one laptop and plus an USRP. This is a USRP B200 and B200 mini type. Okay, we run the OpenBTS software on it. And the right one is a desktop with mini size, the gigabyte. And with then also USRP B210. This computer runs the Open LTE software. It creates a fake LTE network. Here is a short video. Because the whole procedure for the cell phone turned from the real network to our fake 4G network, then to the fake 2G network is a very, very quick process, right? So the video is very short. Only 1 minute, so please watch it carefully. This computer created a 4G network. We sent a touch reject to this MC number. Then we direct it to a given frequency. This is an iPhone. He received a message and keeps staying in this fake network. It cannot go back to the real network. Let's check the computer 2G fake network. The cell phone, MC, blah, 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 is in this 2G fake network. Okay. These slides, I want to discuss the risk of this attack. As I said before, we can use fake base station, and we also can use a raw base station. What's the difference? If we force a cell phone into a fake network, the cell phone will have no service. This means the cell phone cannot connect to the real internet. But we still can do something. We can make malicious call and to send SMS with any calling number. This is quite useful. And in another case, if we build a rogue network, like this picture, this is a femtocell. We hacked it last year. Our team hacked it. We also gave a presentation in last year's DevCon to introduce such how to hacking a femtocell. So this is an authorized femtocell, and it can connect to the operator's network. So if we force the cell phone into such femtocell, all the traffic, the real traffic, can be eavesdropped by the attacker. This is more dangerous. From these slides, I will introduce the principle of how the attack realized. We can see here, this is the basic procedure when the cell phone power on and then connected to the network. It will firstly search the neighboring cell and find a cell has best signal and try to connect to it. It will build a RRC connection, send RRC connection request, and then set up the connection. Cell phone will firstly send an attach request. I mean, I want to attach this network, and then the network will give feedback. Okay, if this is a normal cell phone and normal network, the authentication procedure will be successfully completed, right? So from this red line, the below part, the green part, the safe part. And above this green line, here is the attack space. This part has no encryption, so we can do many things in this space. The three attack, IMSI capture, DOS attack, and also LTE redirection are all happening in this space. Let's see the first attack, IMSI capture, how it realized. Can you see it? Here, firstly, the RRC connection is built. And here, you can see, the cell phone sends a tracking area update reject message. What does it mean? Usually, the cell phone staying in the operator's network. It will not directly send its IMSI number to a new base station because it wants to avoid expose his ID. So usually, it will send a temporary ID to the network by this tracking area update message. Through this message, the network will know, oh, okay, the cell phone is moving into another base station and his position is updated, right? So cell phone will firstly send this TAU request message. Our fake network received this message. It will send a TAU reject. This message will tell the cell phone with a very specific reason. Tell the cell phone, I don't know your ID. Okay, I have no information about you. Please tell me who you are. So the cell phone received this reason. He start a attach procedure. In this attach here, the attach request, the IMSI number is included. And then IMSI capture is realized. Okay, the second example is DOS attack, right? After the step here, after the attach request send out, the fake LTE network will send back the next message is attach reject. This reject message also can bring some courses, the reason why I reject you. I tested many of the courses. I found 4 of them are very useful. For example, number 3, number 7, 8, and 14. What does this mean? For example, for number 3, it means you are an illegal cell phone. tell the cell phone you are illegal. So the cell phone stop connecting to the network and do nothing. And for 7, 8, and 14, they are all related to like tell the cell phone, here I have no service, no EPS, no 3G, and no 2G network available. No network, tell the cell phone. So cell phone shutdown is modern. Do nothing. Then DOS attack realized, right? The third attack, do the further step after attach reject message. When we send the attach reject message, I add, see the red words? Redirected carrier info added to the RRC connection release message. In this message, we will tell the cell phone, okay, you should go to frequency, blah, 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 and a GSM or WCDMA, blah, blah, blah. Then the cell phone will follow the command and enter into your targeted network. Okay, after I introduce the principle, I will tell you how to build it. It's not difficult. You just use computer and USRP or Blade RF. They are both okay. We use a small size desktop and USRP B210. There are some popular open source LTE projects. Two of them are very famous. The first one is Open Air Interface by Eurocom, France. This is the most completed and open source LTE software. It can support connecting cell phone to internet. It means if you build an OAI network in your lab, it can be a privacy network for you, right? It really can connect to a commercial cell phone. But the shortcoming of this project is OAI have a complicated software architecture, so it's a little difficult for a new starter to reprogram it, to modify the code. The second project named OpenLTE, written by Ben, written by only one person. Because it's written by only one person, so the code architecture is very beautiful. I like this code very much. So it's more popular in the security researchers. And, but the disadvantage of this OpenLTE is it haven't achieved stable LTE data connection. But for fake network, it's functional enough. So we finally decided to use OpenLTE. I show you the detailed code here. If you want to try this test, please remember where to modify the code. In the current OpenLTE release, the TAU tracking area update request isn't handled. You can see here is a red sentence. Hey, where's my mouse? Not handling tracking area update request, the red part. But the reject message packing function is available. So what we need to do is just to simply use this function and added some handling code to handle this TAU procedure. It's simple, right? Oh, here is the, I mean, you can handle the TAU reject. Okay. For the second attack, I mean the DOS attack, remember how how we realize that? We send attach reject with some special courses, right? Let's see the source code here. The function is send attach reject. Okay, this function has a parameter. It's the EMM course. You just need to fill the special courses here. Then the cell phone will really shut down. We test a lot of cell phones, especially iPhones. Almost all the iPhones is influenced by this attack. Some of the Android cell phones are influenced. And for the third attack, it's a little complicated. You have to read the 3GPP specification and to know how to construct the redirection message. Here, you need to write the redirect carrier info message and insert it into the RRC connection release message. This function is here, RRC pack connection release message. We need to add something here below for this message. The right picture, you may not see it clearly, is screenshot from our test cell phone. This cell phone is for debugging purpose. It has logging function. So here is the log. I can verify from the log that the cell phone did receive the redirection info. For example, here, this is a GERAN, that means a GSM. And starting ARFCN number is 42. This is the frequency number. So the cell phone will, following the command, go to the frequency 42 cell into that. Okay. Before this slide, or the previous part, I introduced how to do the attack. Okay, but I'm not a very, how to say, I have not very strong attack capability. I'm a lack of the imagination how to do bad things. So usually I will stand at the defender side and to think why there is some vulnerability. Why is RRC redirection message not encrypted? Is there some reason? I asked some of the 3GPP standardization experts, and I find my finding is not new. This is not a new problem. I found a very old document in almost 10 years ago. In January 2006, 3GPP has a document. Here they introduced the forced handover attack. See this part? Compromised network can initiate a reconfiguration procedure with the UE, directing it to a cell or network chosen by the attacker. This could function as a denial of service if the targeted network cannot or will not offer the UE service, or to allow a chosen network to capture UEs. This is exactly what we did. But just at that time, they theoretically say there is such attack, but nowadays we realize it by very low-cost equipment and open source software. And I also find just 10 months later, in November 2006, 3GPP made a decision how to handle such attack. Let's see the 2 points. The first one, RRC signal encrypting and ciphering will be started only once during the attach procedure. after the AKA has been performed and cannot be activated later. But notice the second point. RRC integrity and ciphering algorithm can only be changed in the case of the InnoB handover. 3GPP gives the exception on the encryption algorithm. Here, give an exception. Why? Why make such decision? The standardization expert told me, in some special cases, for example, in earthquake or during some hot events, there will be too many cell phones trying to access one base station, like this picture showed. A lot of the base station is full loaded. Maybe only 1 or 2 base station is light loaded. So they need some scheme to tell the cell phone, go to the light loaded cell phone. This command, why it ignore the authentication procedure? Because the heavy loaded base station has no more resource to complete the authentication. So they wish, they tell the cell phone, well, go to the green one, it is light loaded. If someone argue that, why the cell phone can not auto select another base station? If you don't tell the cell phone which base station is light loaded, the cell phone will blindly and inefficiently search one by one. And this action will increase the whole network load. So this is the reason why such RRC redirection signal is not encrypted. Okay, this slide I show not only the redirection attack reason, but also the other attack reason here. See the left part? The first one is global roaming. The best advantage of cellular network is it has global roaming function, right? That's why IMSI catcher is always successful. Because I can give another example. You know Wi-Fi in Wi-Fi system. Attacker can track your MAC address, right, to know your position. And we also know after iOS 8 and Windows 10, there's some method to randomize the MAC address to protect your privacy, right? But we also know this randomized MAC address only happened under very strict conditions. And there is an exception. If you want to use, let's say, Wi-Fi hotspot 2.0 specification, that hotspot 2.0 is a Wi-Fi roaming specification. As long as you enable Wi-Fi roaming, the MAC address randomization is disabled. The reason is, if you want to roaming, you need to tell the network who you are. You need to first give your ID, and then the network can authorize you, right? So roaming and IMSI catcher is conflicting. The designer has to make a trade-off between them. And also for DOS attack, this is considering to save the battery energy. Suppose if in this environment, there's really no network, the network is broken, no service. So if your cell phone is keep searching the network and try to attach, the battery energy will quickly consumed out. So the designer used such a scheme to save battery energy. Okay, so the third line is this is a conflicting pair, load balance, and redirection attack. I want to say that when we designing a network, we will firstly consider its basic requirement to provide network availability to user. And privacy is a little higher level requirement, right? So it's difficult to make the trade-off. But does it mean we can do nothing? No. For example, I've discussed with this, because the 360 also has a cell phone, making cell phone, okay. So we discussed with the cell phone engineers. We think for the cell phone manufacturer side, we could use two methods. For example, scheme one, let the cell phone don't follow the redirection command, but auto search other available base station. And for and the second method is let the cell phone follow the redirection command, but raise an alert to the cell phone user. For example, you can see a red alert on your cell phone. You are downgraded to a low security network. Do you accept it? You can manually choose accept or not. We know the root of this problem is due to the weak security of legacy network 3G and 2G, right? So from a standardization side, they think it should fix the weak security of legacy network. That means the GSM. They want to fix it. How to fix it? This is a very old network, and there are many old network equipment. It's very difficult to do upgrade. So how to do? Here is very fresh news. This meeting happened just in this month. 2 weeks ago, there is a 3GPP SA meeting. In this meeting, GSMA sent an license statement to 3GPP. This document gives some proposal for legacy security issues and mitigation proposal. For this proposal, the basic idea is they want to upgrade the cell phone side. That means, for example, the future cell phone chipset will have enhanced security scheme. Here are the two example. The first one is the future cell phone may refuse one-way authentication in GSM. For example, a cell phone is in a visited network, and he knows this visited network has 3G capability. For example, he visits Amsterdam here, and he knows here has 2G, 3G, and 4G, right? And this cell phone should use 3G or 4G to do the two-way authentication. It must use that. Mobile refuses one-way authentication on this visited network. But when this cell phone in some very old network, like Africa area, there is only the very old 2G network, then the cell phone has to be used the one-way authentication. So it guarantees the network network availability. The second method is to disabling the compromised encryption in mobile. That means we know that in GSM network, the A51 algorithm is already broken by hacker, right? So this method means the cell phone should not use A51, but use better encryption algorithm in the mobile. So we can see this is a good start for standardization entities. They are trying to fix the problem. Okay, that's all my presentation. And finally, I want to say thank you to some friends from Huawei, Peter Wesley, he is also here today, and to two 3GPP standardization experts, Guo Yi, he's majoring in the RAN standardization, and Chen Jing, he's SA3 expert. And also thanks to Qualcomm, Ge Renwei. He discussed with me the security problem on the Qualcomm's chipset. And also thanks to the Apple product security team. Okay, thank you all. Thank you for your patience today.
Thank you. We have some time for questions.
I think it's clear, very clear, right?
Yes, thank you. The technical details were really good. I guess I am curious, to do the LTE protocol, do you have to have higher bandwidth than what hardware platform you're using? A lot of the consumer grade stuff like Blade RF or...
Sorry, could you slow down and use simple English words?
Oh, sorry. What hardware platform are you using, and does the LTE emulation require higher bandwidth than the GSM?
Do you know USRP?
Yeah.
Yes, but I think USRP2, this board has very wide bandwidth.
So that's B200, I
yes,
think?
Yes, no problem.
Okay, thanks.
Any other questions? Then thank you very much.
Thank you.